Title: Chemical and Physical Properties of Salt. Salt is a ubiquitous substance with a wide range of applications in various fields, from food seasoning to industrial processes. Chemically, salt is an ionic compound formed by combining a cation, usually a metal, and an anion, usually a nonmetal, in a specific ratio. The properties of salt, including its solubility, melting and boiling points, and chemical reactivity, are largely determined by the chemical properties of the cation and anion that comprise it. Salt, also known as sodium chloride, is a widely used compound with distinct physical properties. It is a crystalline solid that is white in color and odorless. The physical properties of salt are determined by its molecular structure, which is composed of sodium and chlorine ions arranged in a lattice structure. One of salt's most important chemical properties is its solubility in water. Most salts are highly soluble in water, owing to the polar nature of water molecules and the electrostatic attraction between the cation and anion in the salt and the water molecules. However, some salts are less soluble or even insoluble in water, depending on the size and charge of the cation and anion, as well as the presence of other ions or molecules in the water. One of the most remarkable physical properties of salt is its high melting and boiling point. Salt has a melting point of 801 degrees Celsius and a boiling point of 1465 degrees Celsius, much higher than other common compounds like water and ethanol. This is due to the strong ionic bonds between the positively charged sodium ions and negatively charged chloride ions in the crystal lattice. These bonds require a large amount of energy to break, which leads to the high melting and boiling points of salt. The melting and boiling points of salt are also influenced by its chemical properties. Ionic compounds generally have high melting and boiling points due to the strong electrostatic forces between the cation and anion in the solid state. The melting and boiling points of salt can also be affected by the size and charge of the ions, as well as the presence of other ions or molecules that can interact with the salt. In addition to its physical properties, salt also has important chemical reactivity. For example, many salts can undergo acid-base reactions, where the cation or anion reacts with an acid or base to form a new salt and water. Salt can also participate in redox reactions, where the cation or anion undergoes a change in oxidation state, often accompanied by the transfer of electrons. Salt is also known for its solubility in water. It is highly soluble in water, with a solubility of 359 grams per liter at room temperature. The solubility of salt in water is due to the polar nature of water molecules and the attraction between the positively charged sodium ions and negatively charged chloride ions and the polar water molecules. Salt can also dissolve in other polar solvents like ethanol and methanol. Another physical property of salt is its density. Salt has a density of 2.165 g/cm superscript 3, which is higher than water. This means salt sinks in water and other fluids with a lower density than salt. The high density of salt makes it useful in various applications, such as in the production of brine solutions used in refrigeration and as a weighting agent in drilling fluids for oil and gas exploration. In addition, salt has a crystalline structure, which can vary depending on the conditions under which it is formed. For example, salt can form cubic or hexagonal crystals, depending on the temperature and concentration of the salt solution. The crystal structure of salt affects its physical properties, such as its hardness and cleavage. Overall, the physical properties of salt make it a unique and versatile compound with many useful applications in various fields, from food seasoning to industrial processes. Understanding these properties can help us better utilize and manipulate salt for our needs. The chemical properties of salt play a critical role in determining its behavior and applications in various fields. Understanding salt's chemical properties can help us better utilize and manipulate this versatile substance for our needs. Potential questions. What is the chemical composition of salt? Why are most salts highly soluble in water? What factors influence the melting and boiling points of salt? Give an example of a chemical reaction that salt can undergo. How can understanding the chemical properties of salt to be useful in practical applications? What is the molecular structure of salt? What is the melting point of salt, and how does it compare to other common compounds? Why is salt highly soluble in water? What is the density of salt, and how is it used in industrial applications?